All right, so imagine a world where wireless technology isn't just something that connects you to your phone, but literally powering the future of connectivity, from security systems to smart cities to game-changing IoT solutions. What if I told you that some of the biggest breakthroughs aren't coming from the big telecommunication giants, but from innovators building bespoke solutions around on the ground?
And today we have one of those innovators joining us. He's a wireless tech expert and entrepreneur, and has been at the forefront of deploying cutting edge solutions in Africa and beyond. Not to mention, he's seen firsthand what works and what doesn't work in networks like Helium.
Joining us today is Keith Vieira, founder of Vibetronics, a company that's pushing the limits on LoRaWAN, GPS, LTE, and custom wireless solutions. Keith, welcome to DadsGoneCrypto.
Thank you. Hi, everybody.
How you doing, Keith? Great to have you on the show. So you've been working in wireless technology for a long time. Take us back. What sparked your passion for this industry, and how did you get started?
I think it started originally when I studied electronics and I did electronic engineering, and it was great. And at that time, wireless was still very young, but it was intriguing nevertheless to say when you worked in a lab and you got a signal from point A to point B, and it's just complete black magic, and nobody could really understand why it worked. But we understood the theory behind it, but you could not see it, you could not feel it, but you could see the results of it working correctly. And that really got me intrigued. So when I finished engineering, I worked as an electronics engineer for some period of time, not in the wireless field, in pure electronics. And then after that, got into the wireless field. And it was primarily at that time, it was wireless technology that was used for sending data from a home security system to a central control room. And when they first started to do what we call today as monitoring and armed response. And it started with the old technology, namely VHF, which is the 140 mega, 150 megahertz frequency. And we had to install all the equipment on all the high points, or what you call now nodes, and then send a signal between 5 and 15 watts, depending on what power regulation was allowed in the frequency. We would send that signal to a high point, and from there we would relay a signal via radio again on the same frequency, because that is all we are allowed to do, back to a control room. And then they would get a signal saying that there was a break-in or a panic signal from a particular premise or house, and then they would do the necessary response. And that equipment we had to design from scratch. It was a started with a crystal-based radio. And we designed that on the frequency and got that working, and had to have it type approved in what we call today ICASA. In those times it was South African Telecommunication Authorities. That equipment had to comply with certain standards, and it was mainly to do with what we call spurious emissions. When it transmits, does it transmit a lot of noise with it, or is it a clean, healthy signal on the frequency that you're allowed to use? And then we used commercial receivers, and later on, as we got better, we produced our own receivers that were more suitable for high sites on top of mountain ranges, in order to deal with the increased load of interference that are starting to arrive on these high sites from various different technologies, including that of GSM and other two-way radio and other wireless technologies. So that's how it started. And from there it's grown. And of course, then the GSM came into the same space. And if you had a power on a site, GSM became a much more efficient way of getting a signal out. If it was a site that was not going to be powered, otherwise battery use, then GSM was not that effective. And hence, that's where the world of LoRa and other technologies developed, where you could use battery-operated equipment that could last for 3-5 years, that could send signals from a different point to another point or to a high point. And that's how the technology, in a very simpler way, it evolved in that way.
Interesting.
So Keith, you've been in this space for a very long time. So you understand how it's evolved, and as new technologies have come in, you've kind of, played with it. But before we get onto that type of stuff, those type of questions, I want to ask you a question. Vibetronics is kind of solving real world challenges that people have in their businesses and their communities and around their suburbs. What was the turning point that made you launch your company? So you had a traditional background, then you merged into, well, let me take this a step further with the technologies.
Yeah. So I think the frustration came mainly being in business for many years, doing primarily sending signals from a house to a control room. And that technology has lasted for many years and it's worked efficiently for many years. But then suddenly it needed more than that. So the company that we owned at the time, we sold the company, and then my son opened Vibetronics, which I am now helping him with. And that was primarily looking at more modern technologies to do a similar thing, and to take, once you have communication from a premises, you are now able to send a lot more information, not purely alarm signal or panic signal. You can now send information such as current flow, temperatures, i.e. you can send signals back. Remember, the technology that we originally used was only single direction, unidirectional. So it was for a transmitter, not a transceiver. It was purely a device that went in the house that sent a signal out. It was completely deaf from a point of view of hearing a signal back. So we wished and hoped that every signal got through. So we had to build in fail-safes with using extra power, more high sites around. And that became a real nightmare, because over a period of time, suddenly we found ourselves with over 800 high sites in the country. Now, that might sound very exciting, and yes, it is, but those high sites have to be maintained and looked after, and they're exposed to the weather. They're on top of mountains. They're exposed to monkeys and baboons that attack the antennas, and it happens every single day of our life. So eventually you have a team of buckies that are based in Cape Town, Durban, KZN, Northern Transvaal, and now Polokwane, and you have these guys running around permanently fixing these high sites, and that's what it cost, and that became really messy. So with the advent of GSM, the world changes drastically. But the problem with GSM is that it can't work on a battery. So now if you want to monitor something slightly remote, GSM is not that great. If you want to monitor something that you want to put somewhere that's very small and discrete, GSM doesn't work. So suddenly the other technologies start to arrive, and we decided then to sell and move on and start a business that does primarily these type of activities, monitoring smaller things, monitoring more things in the home than just an alarm signal, rather using that communicator that is there to monitor alarms, now relay a whole lot of other information through it. And these might be the water meter, these might be your current flow, it might be the temperature of the pool, it might be an alarm signal, it might be anything you want to send through. You have a connectivity from the home already, so now you can add on as much as you want to. And that's where this short range wireless came in, and primarily we use nice technology there, which is simply LoRa and other technologies, UHF technology, and they can operate at very low wattage and very low power, and they can what we call go into sleep mode. So they sit there using very little current. We're talking nanoamps, and they sit there doing that all day, waiting for a change of state, and then they will relay information to a central point in the home, and from there we get it out via GSM or any other method we choose to go.
And for those who are tuning in from around the world, those places that Keith has basically brought up is a place in South Africa. And baboons and monkeys are common here, amongst other things. Lions and hyenas and wild dogs, maybe in the game reserves, But yeah, perhaps Keith can send some photos of his pet wild dogs.
Excellent.
Yeah, it would sound strange for somebody in Europe or America to understand that, but in South Africa, baboons and antenna poles are a real problem.
Yeah, that's crazy. I mean, we have bears here, but that's no baboons climbing up trees.
Yeah, I fully understand. I've got extended family that act like baboons sometimes, and they also make a mess and climb things at times. But obviously involves a bit of alcohol. But so let's fast forward. Let's bring in some crypto technology. Keith, tell us a little about Helium Network. You actually own one or two nodes. What was your initial? What drew you to Helium project, and what was a game changer at the time?
So I think number one, what drew me there, it was the love for RF, and we had reached a dead end with using what we
Is
call
that Roger Federer?
conventional radio, using conventional radio that was big and bulky and unidirectional, and it used a huge amount of power because, as you know, there's in physics you have to have current to have power. So then we realized that there's better technologies and there's better way to do it. And with the advent of GSM using spread spectrum extensively and very effectively, we suddenly realized that that would be the way to go. So conventionally, on using VHF, there's a limitation to the amount of transmitters that you can install because there's one frequency and they all have to speak on that same frequency or communicate in the same frequency, and you can only get one signal at a time. So conventional radio, if you send two signals at a time, they mix because they're on the same frequency. They overmodulate each other, and at the end you might get one or none of those signals coming through. So there were huge limitations in what you could do with a single frequency, not using spread spectrum. With the advent of spread spectrum, it started to change the rules extensively. Now we could send many signals. We're talking thousands and even millions at a time via this way of communicating without them clashing or mixing and each of them getting to a high point. Then it obviously, for us, the pain was always managing and maintaining these high points and these what we call high sites, or what you term as nodes or repeater points. They all had massive big antennas. We're talking 6-8 meter poles with big antennas on top because that's the nature of the frequency. And maintaining these became an absolute nightmare. And for those guys who I sold my company to, they still have legacy products that they still have to maintain like that. And still today, I have lots of communication with them. It's still a nightmare. So with the advent of spread spectrum technologies, it became really nice to use it for short-range communication. So what we call in a local area, like a shopping center or a large piece of land or a stadium or something like that, it became very useful to be able to monitor in that area and then relay the signal out via GSM into a server and to wherever you wish to take it to. In that world, it was great because you now could have remote points that now worked on batteries. So it meant you didn't have to cable things everywhere. And our first experience with this was on a farm in the desert in South Africa called Kalahari, where we monitored pumps and water levels because obviously being a desert, water is critical there. And we monitored there, and there was no power. The pump had power, but where the dam was, where the reservoir was, it was a kilometer or two away. There was no power. So battery operated had to be used, and it worked extremely well, sending signals 1 or 2, 3 kilometers back to a central point. And the farmer was now able to see what was going on at all these dams and all the points. And it opened for us, it opened a new world of not just pure security world or long range signals all the time. It became, we could create a local area network where we could use this wireless technology, and then we could integrate that local area network into a wide area network where we could then relay the signals to cell phones and to control rooms and to anywhere where we wish to go. And the spread spectrum technology really opens a whole new world of that.
Right. Wow. So Helium had a lot of hype early on, but it's no secret that the project has struggled over time. And they had so many miners running that their rewards got really diluted. So people in crypto that were all about the mining rewards basically stopped running their nodes. So from an insider's perspective, what do you think else went wrong in Helium?
So I think the pains that we suffered with that was, I think the concept was fantastic. The pains we suffered with that was, again, local support. We struggled a bit with local support for the Helium nodes. We struggled with that. Secondly, the Helium nodes that you have access to here in this country are not GSM-based nodes, so we had to modify the node to become GSM-based because they were primarily what we call LoRa into Wi-Fi, which is great in a nice built-up area like a big city. It's fantastic when you have them on every third or fourth house. your coverage is excellent. But our problem here is a little bit different because we don't have that luxury of everybody adopting a node and putting it on his house and having Wi-Fi. So the problem became quite problematic later on when we started to install these things, because we tested them in a given area and we could see all the high points and we could see that they were working and everything worked really well at the beginning. And then we started to run into problems where the signals started being dropped and not being received. And then when we went back and we were checking all the time, and we ran a little software in the background, almost like an AI software, monitoring what was going on in the Helium towers, we saw that because they were not managed by one company and they were not seen to be critical installations, we see them disappearing off the network from time to time for quite a period of time. And therefore your signals now get lost. So that became problematic because the average homeowner, when he buys this, he doesn't really understand radio and what he's doing, but he understands he's going to get some rewards in the form of crypto for mounting this, installing this, and leaving it running there on his Wi-Fi. And when the rewards aren't as big as he expected them to be, then there's some frustration that sets in, and some guys just simply switch it off. So what was working yesterday doesn't necessarily work today. So we ran into some serious problems with that, where using it on a long-range basis, the network changes regularly and often, and that can be very problematic when you're starting to send signals through. So that was the downside of it. I think the concept is fantastic, but I think the only real way to do it is, once again, to do it like we did it before, is take over all the high sites around a given area, put a proper Helium or other technology networks there, and maintain them and pay the necessary monthly rentals to use that site, where you have the correct equipment, the correct filters, and the correct power supply on it. And you know that they're up 24/7. And you know that if you test a signal today, it's going to work, and tomorrow, 9 times out of 10, it's going to work unless there's a really big storm or something changes. That is the only way I believe that it can work. I think the concept in Europe is very different, and because the houses are much closer together, I think one node goes a long way. But in Africa, it's very different. And we have experience here and in Botswana, where eventually we just put up all our nodes ourselves in Botswana, and we have a guy that maintains them there, and we get far better coverage like that. And saying that, we do find that if you install a node that is a bit far away from a communicator, because remember, you're only sending small amounts of power. You send in 100 milliwatts at the maximum you're allowed to send, and you're limiting what antenna you can use. So sometimes you have borderline signals. So it's always better to install extra nodes to make sure that. So if you require 7 nodes for a particular area, rather install 10 nodes, make sure you cover them more efficiently, and then you have guarantee of a signal all the time. But that for me is probably the safest way to roll it out. The technology is absolutely brilliant. The LoRa technology is fantastic. As is some of the narrowband technologies like Sigfox. I mean, they don't use spread spectrum, they're using narrowband, and it also works really well. But again, they control all the high sites. So LoRa's Helium's downfall, in my opinion, in this country, or maybe its downfall is simply that. There's nothing wrong with the technology, there's nothing wrong with the companies, nothing wrong with their servers. It really works well. It's simply the people that install these nodes don't have the same level of commitment as what we do to make it work all the time.
And I think it's an important lesson because as innovators in the space, they come and they design this concept. Well, if every household or every third household buys this and installs it, there is coverage, right?
Yes.
Then there's actually the real world application. It's like, okay, now that my idea of everyone having one, now not everybody's going to have one, and I'm putting it on every fewer houses, and it doesn't really kind of work, right? So that's where I think maybe companies like Helium should gather that information and find better solutions, right? Or perhaps a better rewards model or a better incentive program to keep it going, right? Or basically integrate technology whereby it's not a standalone technology. Maybe it's a a node that works for multiple things and just so happens to have LoRa built into it, then it's using it for a multi-purpose situation. Then it's not a standalone item, because you don't end up one of the day have like a wireless, a LoRa, a low band, and all these other things, because then it kind of complicates your whole setup from a private person point of view. But I agree with you, all the high ends need to be controlled and maintained, which is difficult, because then you're dealing with businesses and they want to cut and they don't understand what you want, and it becomes quite expensive. And also you need adoption. If you don't have adoption, then you put up all this infrastructure, you got all these costs and running costs, and you have no one really kind of using the services as you would like. So in understanding this, just outside Helium, you've also started to understand the problems, right? Especially in this particular country and the rest of Africa. And Africa is a big continent, all right? So you can't just say, well, forget about South Africa, forget about Botswana and all these other African countries. It's a continent, right? And it needs real world solutions. So you started to develop your own type of technologies for real world problems. Can you just give us some, you alluded to us like that the farmers needed to understand water and levels and so forth, but what are some of the real world problems that you are solving at the moment that you're making money off and that other people are making money from it?
Yeah, sure. So let's just go back one step and let's just dwell a bit more on the LoRa side. So there's two areas. If you're talking LoRa, we're talking LoRaLAN, which is the local area network, versus the LoRaWAN, WAN, which is the wide area network. So the wide area network is where Helium plays, and that's where you install a device and it communicates with a wide area network. And once it's in their cloud, you can access that information and do anything you like with it. The problem, as you mentioned, is that these high sites come and go and get switched off and switched on, and not everybody at the home's got UPS. So when there's a power failure, you might lose 6 or 7 high sites in a given area, and then none of the signals come out. So for us, we going more towards a LoRaLAN type thing, which means it's a local area network. And that might be, let's give an example, like a shopping center. For example, we'll put up one central node which receives LoRa and takes that information and puts it through Wi-Fi if it is there, or puts it through, in this case, through GSM. We have both on the nodes. It comes through GSM and Wi-Fi, and then it goes into the cloud and we can use it. Then in the shopping center, you can install as many LoRaLAN devices as you wish. So therefore, it starts to open a lot of doors as to what you want to monitor. And many people are not even aware that they can monitor these things. So originally we started with a device that monitored. The name came from the name Vibetronics came from us monitoring one or two major devices, which I don't want to mention the name of them because they are quite sensitive. But we were monitoring the vibration of these particular devices. So this was a machine that had to run at a certain revolutions and had to be very smooth. And we then install a vibration sensor onto this. And this vibration sensor obviously measured the pattern of this particular revolution. And if that changed within a certain algorithm, it would then send a LoRa signal to us to the point, and that node would then transfer into GSM, send it to the server, and then we would send this information to a cell phone, either in the form of an app or a push notification to say machine A seems to be either overloaded, because the moment you load these machines with too much, that's when the vibration goes out and you wear the bearing. And he needs to know this information because these things run 24/7. So he's not always there, but he needs to know that information. And that's how it started, monitoring a thing like that. And we still have that running. And it's a very specialized thing because every machine is different. So the device has to have self-learning. So the device is installed and then it runs for a period of time on a selected load. And if that's correct, it then learns that pattern and says, okay, what does a heavy load look like? What does a light load look like? And now I can report these two exceptions. So if the machine is running for a prolonged period of time with a light load, then somebody's not doing their job correctly, and then that information is relayed back to the owner or to one of the managers. And if it gets a heavy load, obviously somebody's loaded it too heavily, and that information is relayed back. So that's how it started. And then it started with monitoring water. And in South Africa, as you know, water is becoming more and more scarce, and it's very critical. So these devices can be installed on a water meter coming into the house, and it can really tell you how much water is being used. For example, you could say, well, I shouldn't be using water at 2 o'clock in the morning unless I have a leak. So it will then say to you, there's a problem. You used X amount of water at 2 o'clock in the morning. Between 2 and 4 o'clock in the morning, you used X amount of water, which would tend to point to a leak. Or if somebody leaves the tap on all the time, water runs for a period of time, and therefore the software in the edge computing at the point will say, I've received too many signals for a period of time, and it'll also send the number of liters being used out, but it also sends a signal to say, this is out of the norm. So you can monitor that. So these things now start to change their form, and you can start to use a lot more things on the home that you couldn't monitor before. The secret is we also went down the road of having all our transmitters were helium based, but as you know, we just ran into problems. So then you had to run back to water meters because they weren't working. So we prefer the route of a local area network into GSM or into some other, even into LoRaWAN if the signal is really strong there, and then into a server. But LoRa is a very efficient means of communicating a radio or wireless signal from point to point. Whether it is going to ever be suitable in Africa for a wide area network, I am not convinced of that. It most certainly, in its design, it can be, but the implementation, as I said earlier, is very much more complicated because it means a lot of high sites, a lot of maintenance, a lot of monitoring of these high sites. Because the signal travels a certain distance, but obviously we don't have the luxury of every single house like in Europe, where every fourth or fifth house, and they're very densely populated, there's no problem getting signals out there. I believe in London, you can send a signal from a drain in LoRa in the middle of London, and it comes out, which is fantastic. That's exactly what it's designed to be doing. It's designed to monitor all that. But in Africa, the problem is a little bit different.
So are you still using, you said you're focusing on local area networks. Are you still using the Helium Network for those networks, or are you using your own?
No. So on the local area network, we use a LoRa device that is coded for battery operators. So, you have different types of LoRa that you, when you write the software for them, you have a choice to say this is battery operated, so therefore it uses less power. And it regulates the time that it's on the air depending on how far the receiving device is away from it. That's where this technology is so clever. So if you're in a house and you're 15 meters away, obviously the signal can be very quick and very short. So the time on air is very low. If you're sending a signal 1 kilometer, the time on air has to be much higher. So we use the short range signals, sending information from points to a central point, which is maybe 100 meters away at the most, or maybe sometimes it's a kilometer away, but not normally. And then from there, we take that into either GSM or into some other technology, but primarily into GSM. And from there, we send it to wherever it needs to go.
Gotcha.
Yeah. So, for example, we are running a test system on pipes now, because we know that there's cable theft and there's pipe theft in South Africa. And this is a unique problem we have. And we're running tests on that where we install a device on a pipe, and then we can measure about 65 meters to the left and right along this pipe. We could even see if what we call a large bird, we have large birds here that fly around our yards in Africa, and a large bird called an iris or ibis or horida, if that lands on it, we can pick that up. So this pipe then, so if somebody comes and starts to pull these pipes out with a truck or starts to cut the pipes, we can sense that and relay that signal back to somebody. So it's very effective from that point of view. But again, that would be on a mine, for example, or a big construction site or a big industrial site where the signal goes maybe 200 or 300 or 400 kilometers back to a central point and then into a GSM and so on.
Gotcha. So do you think there's still areas where the helium application works well, or is it do you think it's being replaced here?
Yeah, I think helium needs a bit more time to grow. I believe they are installing and they're selling a number of these helium nodes every single month, so they must be going somewhere. But again, it's whether they get into your area or not. That's the biggest problem with it. So I think if you're going to go using helium for long range LoRa, and you want to go countrywide, or you want to go a large area like the whole of Johannesburg, and all the suburbs of Johannesburg. And I would say that you need to then invest into some high points where you install these and you maintain them and you ensure that they have the right power supply and that they're on 24/7. Otherwise, I think you will run into problems where you'll start missing signals and you'll spend a lot of time and money trying to debug this.
Makes sense.
But it's great technology, and I think the concept's very good. I think just the adoption process in South Africa or in Africa is maybe slower than what we would like to have been, and therefore using it for long range is a little bit risky at this point.
So security is a huge issue across many industries, obviously. Can you share a real success story where wireless technology made a measurable impact?
No, absolutely. So I think the security industry, in Africa, primarily because, previous business, which was primarily supplying security communication equipment. So in Africa, without that equipment, our security would not be. I mean, we know that in South Africa, the nature of our security is very different to that of the rest of the world. And we know that we have violent crime and we need to send help when somebody pushes a button or when an alarm signal goes off. So that I can't mention figures of what the previous company I owned is presently doing, but they have in excess of millions of signals going through daily of these signals, and whether it be monitoring such things as low batteries, because we know that the criminals have learned to switch off the main supply before they come into your house. So in many parts of South Africa, we still have the mains outside on the street, so they've learned which box belongs to which house. And they simply switch off the mains before they break in. And then sometimes the battery in the house still works for a period of time, and sometimes it stops working because the batteries are old and never been maintained, which is typical of most security installations. The homeowner, the last thing he's going to think about is replacing his battery. It just doesn't think about that. He has many other things to worry about. So they would switch that power off, and then they'd wait for an hour, and then they would try to break into the house, and the alarm would not be working. So we need to monitor things like the power. So power on, power off, we have to monitor all the time. So if there's a fluctuation in the power or a change in the power, we need to report that all the time, because that generally preempts a burglary. And then things like low battery, we've gone to a lot of development of technology that can manage or control a battery while it's still working without having to switch it off and load it and test it to see if it still works. So while it's working, we can check that battery and send a battery status before this battery needs to be replaced. So we can warn the security control, guys, this battery needs replacing in the next 1 month or 2 months because it's going to stop working. So that, and that's pretty common. We do that all the time. And then, of course, the normal alarm signals, we send millions of signals around the air every single day. Be all nature. So in South Africa, the insurance companies require that if it's a business site, they need to know when the business is opening and when it's closing, and they need to know statuses of power and battery. So every time you open your business, we need to relay a signal back to control to say that the owner opened his business at 7 o'clock in the morning, and the power is like this and the battery's like that. Great. And then he locked up at 5 o'clock in the afternoon. The power's like this, the battery's like this. System is all armed. No zones have been bypassed because many security problems that exist are inside jobs. People that work there that would bypass a zone before they came back in the evening to break in. So we report if a zone is bypassed. So we report a signal has been armed, the alarm system's on, but zone 12 has been bypassed. So that is recorded and everyone knows about that. So those are the things we do all the time, and thousands of those.
Interesting.
All right. So, Keith, obviously security in South Africa, I think we pioneered this space for the rest of the world, just based on the complexities of what we have to do on a yearly, on a daily basis, just to run businesses and so forth. But at the same time, that's the beauty of technology, is helping solutions, right? And then, expanding that. So, you spoke about technologies. I think you were alluding to someone in the mines, if I'm not mistaken. Maybe the platinum mines. That sounds familiar because my wife was, she's worked as a program manager for Anglo, and it sounded all very familiar. Now, you've done farms. You said solutions for farms, solutions for security, solutions for mines, which is $1 million industry. If someone was starting to talk about, opportunities in this space, what other areas could people get excited about? Because they're putting up these bloody things all over the world, right? But where does the true opportunity lie where, adoption could take place for more usage and real world usage, not just a doorbell that, my door's opening and closing, right? It's great if, if you want to know what time your wife comes home. But apart from that, like real world stuff.
Yeah, so I mean, most certainly on the residential side, on the industrial side, there are many solutions and there are inquiries every day. We just don't have all the sensors for what they require. On the residential side, and I'll come back to industrial, on the residential side, I mean, we have to look at where the key areas that are costing you money every single month in your home. And in South Africa, it's water and electricity. Those are two things that have become both problematic and expensive. Okay, so electric usage is very easy to monitor, and whether you're monitoring that on a certain area of the house, you say, I want to know what these rooms use or what the house uses or what this machine uses or what my computer uses, these sensors are all available. If you want to know that when you go out and you're halfway to going for dinner with your wife and your wife says, I think I left the stove on, you can quickly look on your app and say, no, the stove's off. Sorry, no, stove is on. So a little sensor that goes on the stove, it measures the current going to the stove, and you're on your way to dinner. And she says, I think I left the stove on. No, the stove's off. Or yes, the stove is on. And that's a simple thing like that. And it costs you a few rand or cents a month. And you have that luxury of saying, okay, the stove is actually off or the oven's off and so on. And these are things where it's coming into real life use. And in areas where you wish to monitor something remotely. So, for example, if you are at home, but you want to monitor your restaurant at night, besides having cameras, you can watch what's going on. If you have some sort of interface to some equipment there that you want to monitor, whether this is on or that's off, or whether it's on for a certain period of time, or you want to count on operations somewhere in a restaurant or a night shift work, you can get all that information on your cell phone. So at a glance before you go to sleep, you can see that everything's working like it should be working, and there's no problems that you need to go investigate. Because obviously cameras can't show you everything. Like if the guy's not doing his work, but he's back to the camera, you don't really know if he is packing something or not packing something correctly. So there's advantages in that. On the industrial side, there are inquiries on a daily basis for sensors that need to be developed. So the Chinese are pretty well down the line of developing sensors, but they develop sensors for, I think it's a group of guys, or lots of Chinese guys that have many great ideas that develop sensors. I've never yet just bought a Chinese sensor that actually does what it's supposed to do, what you want it to do. It does what it says, but it doesn't quite work in your application because our world's a little bit different. So I've had boxes full of them that I've tried over the years and tried to implement one of their sensors. I mean, the sensor works. You're not buying a dud, but it just doesn't do what you want it to do in this environment. So either you're going to go back and get somebody in China to change the software, which is a very big job, because the language barrier, time barrier, and their interest in doing it, because they would all want an order for 20,000 pieces before they changed one line of code. So it becomes a little bit difficult there. So the problems that we have experienced here in Africa is really we have to start developing more and more sensors for ourselves. And these sensors are not difficult to develop. It's just about getting the specifications correct of what you want to monitor. And that's where the things like vibration sensors came in very handy. We're now monitoring. We have a product that fits onto your gate motor on your house or your premise or your work. As you know, in South Africa, most entries into properties are lifting gates, the sliding gates. They lift the sliding gates. They're open enough to get inside. And once they're inside, they can tamper with the gate. So we have developed a device that goes on that measures if there's any vibration on the gate, if the gate's been opened without a legitimate signal being received. We monitor that and we report that to two places. One, to a security control room if you're connected to the security control room, and the other one to the homeowner. We wake him up at 2 o'clock in the morning to say, listen, problem, you've got somebody at your front gate trying to get in, because he would sleep right through it, he wouldn't know it. That product is selling really well because it's a real life problem here in South Africa and in Africa as well. We're starting to export those to Kenya. They have a similar problem in Kenya, believe it or not. So These are problems that we are solving all the time. So again, and also what we are measuring on the gate, it goes a little bit further than just saying, oh, there's a unlawful entry. We actually measure the pattern of the gate every time it opens and every time it closes, and we say, okay, this is a good pattern. The rollers on the gate are really working well. Everything's fine. If those rollers, as we know, after rain and etc., so water being on them, they start to change their nature and they start to become a bit sticky. And then you can measure this pattern and you can warn the homeowner to say, yeah, your gates need lubrication, or the roller's wearing out, or the track is very dirty, whatever may be the case. So this is a real life application that you can stop a gate from being left open, or in the case of reopening when you drive away, so because the gate hit a stone on the track, or the gate roller is sticky, so you drove away, you closed your gate, you think it closed, but in actual fact it didn't close and it stayed open. And these are real life problems so we are monitoring gates in all of those areas. We monitor where the gates left open, if it's been open, who's opened by. We record all the information to say that this gate was opened by person A or person B at this time of the day, and it was closed by person A or person B at this time of the day, or it is left open at this time by person A. And so all this is recorded for the homeowner to look at. He just goes into a web portal, he looks at it and he says, oh, okay, this is what happens with my gate, and this is what's going on with my gate. So as well as an unlawful entry, we're monitoring all those things on a gate, because, as you know, we use our gates all day in South Africa. We can't have them left open.
Keith, could you send a signal via LoRaWAN to, let's say your gate is open, you left, you're going to a party. Can you just on your phone say, okay, close the gate, and it'll tell you that the gate is closed? Absolutely. Is that possible?
So okay. There's two areas of the gate functionality. One is the big unit that's got GSM, because there's power at the gate and there's constant power. So GSM is power hungry. So the GSM unit has a full app that you can open and close your gate at any time of the day for anybody that's there, or you can get signal and push notifications because you have an app to say your gate is open, your gate is this, your gate is that. So you can most certainly open and close your gate. I use all day on my gate. I don't use remotes on my gate anymore. I just flick my phone open, push open, and it goes through, because it tells me more information about what's going on. So it does that. When the LoRa devices, unfortunately, we tried to do the same technology via LoRaWAN, and again, we ran into the problems of connectivity in all areas at all time. We have many LoRaWAN devices on Helium working really well. And that's where there's a high concentration of nodes. They're really working well. The technology is great, and I really believe in it. So what we do we can put a small little LoRa sensor on your gate. If you don't want all the bells and whistles of having an app to open and close your gate, you just want to monitor if your gate's been opened illegally, you can put a little LoRa sensor on that measures the vibration of the motor and says, this gate was opened illegally, and it reports that signal to your alarm panel. So it sends a local signal on your premises to your alarm panel. The alarm panel then has, of course, all the bells and whistles of being able to communicate with the control center, and then it will relay a signal to the control room or to you via GSM. So you don't necessarily have to have GSM in your gate. So you can have two different models, and that's where we use LoRaWAN for that application.
Interesting. That's really cool that you can actually monitor how well a gate is opening. I think that's interesting. And did you guys develop that on your own? You developed those sensors?
Yeah.
Okay. Yeah. You developed it? Wow.
Yeah, we developed ourselves. Yeah, absolutely. So, I mean, the sensor world is a very nice and very exciting world to develop, because, as you know, microprocessor technology has come such a long way now. There's so much memory in a little micro. I mean, the thing is 5 mil by 5 mil, and it's got a huge amount of memory. So you can do a lot of processing at the edge now. So you can do a great deal of thinking and processing at the edge. You don't always have to go into the server to process. So yeah, the sensor world is really growing, and it's a great world to be in. It's exciting.
Very cool.
All right, so let's shift some gears and let's talk about ChirpWireless. So we've talked about, a bit about Helium. So Ryan, maybe kick off, because you and I own some ChirpWireless systems. Can you just give us an understanding of what is a Chirp miner and how is it different from that of a Helium miner or Helium? Yeah, it's a miner, a Helium node.
Yeah, I mean, ChirpWireless, it's taking a different approach to decentralized connectivity. Unlike Helium that relies on an absolutely enormous number of nodes and basically single protocol per node, Chirp is focused on creating a seamless, scalable network that integrates with existing infrastructures. And Chirp's multi-radio approach means that it combines LoRa, Wi-Fi, mobile CBRS, and multiple networks into each node, and it offers a whole lot of better coverage and reliability. Plus, it's designed to avoid some of Helium's key issues, such as reward dilution and node abandonment, because they focus on quality of their nodes rather than quantity. So with Chirp, you basically can cover a very wide area with and a very large number of networks with a single node rather than having to have 10 nodes in a neighborhood. So that's my opinion on why Chirp is a little better. It's newer. It's got advantages over Helium. But Keith, have you looked into Chirp at all? And what's your take on how it compares to Helium?
Yeah, so the only information I can get is from the website, and it doesn't quite go into any detail of how these nodes are installed or placed, or even how they decide where they go. So I couldn't quite see that. I can see the technology is great, and I can see they integrate into many technologies, and that looks fantastic. I just didn't understand how they deploy these nodes and what is the plan of deployment of these nodes. And I think that's the fundamental thing for Helium as well. In Africa, let's not, Helium overseas is fantastic, and I think it's a great product, but in Africa, it's a very different set of rules here from a point of view of deployment of nodes and the population of nodes and where they need to be, because these nodes are critical that they're in the key areas.
Right. With Chirp, I know as of now, basically you can buy a Blackbird miner, their node, and install it pretty much anywhere as long as you're not. I think it's within 300 meters of another node, and I know they're currently building that network out. Here I'm in Ohio, in the United States, and there's only three nodes running in all of Ohio, and obviously we're not covering that wide of an area. But as Chirp Network expands and they get more and more people into it, I think we'll see that grow significantly. And I assume that's kind of their biggest limitation right now is just coverage.
Yeah, so from a LoRa point of view, Chirp is also governed by the same rules that Helium is governed by, the amount of power that they can transmit and the size of the antenna that they use. So the laws of physics will still apply to that. I'm just not sure what they do differently that they can cover better. I think it's all about how you deploy these and so on.
Right.
So the methods and the infrastructure, and then creating an ecosystem that it can thrive in.
Yeah.
So in understanding this technology, right, we in crypto space we love decentralization, where the user does not, there's no central point of authority that kind of controls your information, dictates your information. And here's an example, right? So think about the control systems, and this has happened to my parents, where they've had some massive break-ins to their massive safes that they've had. Not that they've got massive safes in their factories, but anyways, and it was an inside job, right? So using that radio frequency technology, they could see, the battery is now old or weak. Yeah. Therefore, if I cut the main power, that battery would not send a backup signal to the control center, therefore giving us 2 hours before anybody actually knows. So that is the problem with centralized information. You're sending all my house information to a control center where some devious person can actually look at it and say, well, the missus gets home at 5, dad gets home at 9 from the pub, and now that's the perfect time to charm the missus. So the point is, in moving to decentralization, do you think that this technology would be totally decentralized, where I'm responsible for my information only, and Keith can't look in on my information because I've got a contract with Keith?
Yes and no. So I think with device, so if we talk about the way the signal is sent, everything is encrypted in that, so there's no problem with that. What you need to do on the site to avoid inside jobs, which are in South Africa very common, is you need to have a separate device that monitors that wirelessly. You can't run cables across because somebody just follows the cables and cuts it, and that's the end of that. So the alarm system needs to have a wireless device in it that talks to another wireless device, and that external or separate wireless device is remote and nobody knows where it is, and that then talks to the network and the security companies and your phone and your parents' phones, wherever you wish to go. And if there's communication lost or if something changes on the alarm, and the alarm signal now is disabled, that it can't send a signal to the security control room, this second device, and these devices are inexpensive, will now send that information to say, this has been disabled, guys, there's something going to happen here. And that's how you can do it. And protecting that information is, I mean, the LoRa stuff is very difficult to tap into and listen to. You can't do it, as is GSM. They're similar technologies. So I think that's, from that point of view, it's a pretty safe signal. You're not going to get around that very easily. And we do that the same on vehicle tracking. We do that now. Well, not we, I don't do it, but the vehicle trackers do that, where they have secondary devices that are not linked, because most primary devices are found, and the secondary device then takes over and communicates.
So, Keith, correct me if I'm wrong here, but with Chirp, we're talking about the network coverage and the difference between Helium and Chirp. Now, with Chirp, because they're combining a Wi-Fi as well as cellular network within their units, along with the LoRa, is it possible they don't need the same number of node coverage as Helium because they can actually send those signals via cell, or am I incorrect there?
So partly correct and partly incorrect. The law of physics says that a radio signal of 100 milliwatts, will transmit a certain distance over a certain terrain. The receiver on the other side, the LoRa receiver, has a thing called a sensitivity of minus 139 dB, which means that it's very sensitive. And that will receive a signal depending on where its place is. Now, if you take a perfect terrain where you have a mountain and you have another mountain and they are 20 kilometers apart and there's nothing in between, that radio signal, 100 milliwatts, will travel right across the other one. And if the receiver on the side has no other equipment around it that interferes with it, it will receive that signal very clearly. So there you get 50 kilometers, lovely, no problem. If you go and you only go 1 kilometer, but there's a building in between you, there's a tall building in between you, and you're trying to communicate 1 kilometer, or 3 or 4 buildings in between you, there's a good chance you won't even transmit 1 kilometer. And that's the law of physics. So it's got nothing to do with Helium or with Chirp. It's just the law of physics of how the signal is sent and how the signal is received. If Chirp is able to deploy these devices onto strategic high points with the correct equipment, so when I say correct equipment, it's the correct filter systems on the front end. The front end is where the signal comes in. If most of these high sites, if you drive around, I'm sure it's the same in America, and you'll see there are a multitude of antennas on a high point. So any high point becomes very popular for all sorts of people to use, because that's the law of physics of radio. So the more interference on that high point, the lower your sensitivity goes of your receiving equipment. So whether it be Helium or whether it be Chirp, they're using the same technology. The receiver becomes less sensitive, therefore your range is drastically reduced. Hence the way that I think that Helium and maybe Chirp are thinking is that they have many of these sites on houses that are clean and there's limited interference there. You get a better reception of signal there. So there's two ways of looking at it. If you're going to go to the highest point and you're going to have a Chirp or a Helium station up there, and you have the correct filtering mechanisms there, you will get a long range and then you'll get great coverage. If not, you've got to come down to a lower level where there's lower levels of interference. Obviously, the signal doesn't travel as far, but because there's interference, you get what we call the same link budget. Link budget means the amount of power you transmit and your sensitivity of your receiver. That is the link budget. If the sensitivity of the receiver is reduced by noise and interference, your link budget goes out. If the transmitter's power is reduced by the amount of battery power left, the link budget goes out. So 100 milliwatts that's transmitting to a receiver that is minus 139 dBm gives you a certain link budget, and that would be equivalent to some 5 watts going to 118 dBm receiver. So The principles of physics are the same. It depends on how you deploy your equipment and what care you take about employing that equipment. That's really what it comes down to. And that's been the problem in Africa.
Yeah, because I know Chirp is very stringent on where you're allowed to deploy. They require you to, have it at the highest point of your property. They make you take pictures to show that you've installed it. And I know they definitely use pretty high wattage output as well, and large antennas from what I understand compared to others. But
yeah. So that really depends on that. And I think Helium also have those regulations, and they also monitor that. And you also send photographs, and you do it well. It's all good. It's just that, and in principle, if everybody just left their equipment on, all their Helium stations on, and they all got paid lucratively, it would be a very happy position that would probably work perfectly. I think where it falls apart is not in the technology, but maybe just the implementation. Well, I can only speak for I think the average person that doesn't make as much money as he thought he was going to make out of it, because as we said earlier on, Sean said, it hasn't been rolled out yet. It hasn't been deployed in all homes yet. Not everybody's monitoring water, electricity, vibration, and other sensors. It's just not happening just yet. So it's a catch-22 situation. If there were many people striving for that, I think there would be a higher deployment of high sites, and most people leave it switched on, and then I think it would be a very successful thing.
And I think that's exactly what Chirp have done. They've integrated multiple technologies to solve some of the problems that have happened and left kind of Helium in the dirt because they haven't rolled out their whole business plan. It's like, okay, cool, go buy the node. Yes, we get money for the node, and we got a bit of money to splash around in crypto. The hype pushes the price. Everybody gets paid. Happy days. But if you got 5,000 of these LoRa's running around your city, but no one's actually buying application, not buying a LoRa device or using the application and purchasing and causing that revenue share, the system's flawed because you're using up your own time and internet and bandwidth and all of that and infrastructure, and no one's buying anything. So they haven't created that model yet. And I think that's maybe where the flaw with these companies is that they should have a representative in each city to say, hey, these are the products, go out and sell, make your life easier. For next to nothing, you can set up your whole wireless home, that type of thing. But it's time. And obviously when you want to try to do a global sell, all right, I suppose you have to have teams that target this. But anyways, that's another story.
So Keith, you're constantly working on cutting edge projects. What's something exciting that you're developing right now?
So we're working with some mining companies predominantly, where they have multiple problems. Whether they have cable theft, they have pipe theft, they have pumps that don't work, they have blocked pipes, and so on. So we're working with a particular group on one project to try and solve all these problems for them. And if that works, then we can roll it out. They'll obviously roll it out to all the mines, and they'll roll it out to other industries that have very similar problems like that. And we're using LoRa technology for that, but it's a local area LoRa technology into GSM and into the server, and then sending signals back to them. And that's an exciting project, big project, exciting project. But because the sensors there are many sensors that need to be developed, and interesting, exciting sensors. I know other guys in this field are working in agriculture, where they're monitoring soil humidity, the amount of water that's being used in soil, whether the soil is too acidic or too alkaline. We don't play in that space at all at this point in time, but I know there are a number of guys working on projects like that.
Very cool.
Yeah.
Very cool. And Keith, someone listening to this podcast that's inspired by, obviously your journey into the space and, taking traditional electronics, then moving into wireless technologies, and now into the crypto space. For someone that's wanting to get into this wireless technology industry, what advice could you give them to get started in the space?
So I think there's always a fear. Every electronics engineer that I speak to that studied electronic engineering, that didn't specialize in wireless or radio, they say, oh, black magic. And it really sounds black magic, but it's not really black magic. There are basic laws of physics that really make it work. And it's a very exciting field because you can now have signals being sent everywhere and things can operate remotely without any cables going across, because I think every electronic engineer hates cables because they just get in your way when you're working with everything. So it's a lovely field that I would say not to be afraid of radio. I mean, you don't have to become a radio engineer anymore to make a radio work. You can buy modules now that work for you. Not like when we first started, we had to really spend months trying to get a radio to transmit a clean signal that complied with what we call telecommunication specifications. That's not required today. So the black magic of that part of it is gone. It's really now you can put a module down, you can write some software to it, and it starts to communicate. And that makes it very, very exciting. So I would say anybody that's in that field that wants to play in that space, there are many avenues to follow today that are not very complicated as it was previously. These modules make life so much nicer and so much easier and so much more exciting because you can do so much more in the same period of time.
Very, very cool. And Keith, if someone is looking for a bespoke wireless solutions, whether it's Helium or Chirp or Community, they've got ideas of perhaps wanting to scale their business idea or, get involved or you can build something for them.
Yeah.
What is the best place to reach you and how do they get hold of you?
I mean, they can obviously, you can use my email address with the greatest of pleasure. I have no problem with that. They can phone me or they can contact Vibetronics through their website. It's fine. If it's an idea, bounce it off me first, mail me first. Let's talk about the idea, because many people have lots of ideas, but it's not that easy to implement all of them. But I have years of experience to say, well, I think this could work, and it'll involve maybe 40 hours of development or 100 hours of development, and it can work, and we can get somewhere with it. I would be glad to talk to anybody on that.
That's great. We'll put all your contact information in the description here so people can get a hold of you. But wow, this has been a fascinating conversation. We covered Helium, Chirp, custom solutions, and where wireless is headed. Do you have any final thoughts you want to leave our audience with? Yeah,
so I think the world of IoT is in Africa and South Africa, it's only just starting. There's a massive world. And the average person doesn't even understand or know or realize what he can monitor. He just has this problem that he doesn't know how to get around. I really do believe that we should have more IoT chats that are related to our environment. I mean, I know the States is very different to where we are, but in Africa we have a different set of problems that IoT can really help a great deal, and it can make life a lot easier for those who are running businesses or have problems that they need to solve. There are many solutions that we can use for that. I mean, you mentioned IoT, everybody thinks home automation, you can switch on a light. Well, it's not about that. It's really about meeting a need where you have a problem, you have an environment that doesn't work for you, or you have something that's not responding, and you can remotely control this and see what is going on. It's really good.
Brilliant. And to our listeners out there, if you got some awesome, clever idea that you want to bounce off to Keith, we'll share your details below, or his details below. And who knows, that solution that you solve might be able to be scaled worldwide. Keith can help you build it. So we'll drop you. Keith, thank you very much for your time and sharing your knowledge with us. We really appreciate it, and wish you all the best for the future.
Thank you. Appreciate your time. Thanks, guys. Really. Thanks, Greg.
Thanks a lot, Keith. It was really great to meet you. Take care. See you guys. The material and information presented in this recording are for entertainment purposes only. Do not misconstrue what you hear as investment or trading advice. Always do your own research. The views, thoughts, and opinions expressed by the guests on this recording are their own and do not necessarily reflect those of DadsGoneCrypto or its hosts.